Welcome to the Deep Dive. We're here to cut through some of the noise around the latest tech buzz.
Yeah, get right down to it.
Exactly. Today, we're tackling a big one, Retrieval-Augmented Generation. You probably hear it called RAG.
RAG, yeah. It's everywhere now.
It really is. But it often gets wrapped up in pretty dense technical jargon. So our mission today is to kind of pull back those layers for you.
Demystify a bit.
Right. We want to get into not just the high-level idea, but also show the sort of elegant simplicity behind it, and then, quickly look at the powerful stuff that's making it work in the real world.
She does that.
Because the core idea RAG brings is, well, it's pretty profound, actually. It lets these large language models, LLMs, dynamically tap into external specific knowledge, basically your own up-to-date data.
To make their answers better.
Precisely, to inform their responses. So we'll dig into how that works, drawing from some, foundational guides and more comprehensive stuff.
Okay.
So large language models, LLMs, incredibly powerful. No doubt about it.
Absolutely. They can write, translate, answer questions. It's pretty amazing stuff.
It really is. But, here's where it gets really interesting. Despite all that power, they have some real limitations.
That's definitely true. There's a great analogy for this. Think of an LLM like an over-enthusiastic new hire.
Okay.
They've read, everything in the company library, tons of information, but they sort of refuse to keep up with current events.
I know the type.
Right. But they'll still answer every single question you ask with total confidence.
Okay, I see where this is going.
Yeah. And that confidence, when it's not backed by current or correct info, that leads to what we call hallucinations.
Hallucinations, where they just make stuff up, basically, but sound convincing.
Exactly. They state things that are wrong or out of date or maybe just way too general. We saw that big example, didn't we, when Google Bard first launched?
Oh yeah, the James Webb Telescope thing.
Right. It gave a factually wrong answer about it.
Yeah.
And that reportedly, knocked about $100 billion off the company's stock value. A huge impact.
Wow, just from one bad answer.
Well, it highlighted the problem, didn't it? And it's not just about being outdated. LLMs can also really, misinterpret the context of information even if the source itself is factually correct.
Think so.
Well, there was this case with a buck title. The title was Barack Hussein Obama, America's first Muslim president? With a question mark, right? Rhetorical.
Okay.
But the LLM saw that title, missed the nuance, missed the question mark entirely, and just stated confidently that the U.S. has had one Muslim president.
Oh, wow. So took a rhetorical question as a statement of fact.
Precisely. It shows how much they can struggle with, nuance and figuring out the actual intent behind the words.
So, okay, these models are powerful but flawed. They can hallucinate. They can misinterpret things. How do we make them more reliable, more accurate?
Well, that's exactly the problem RAG sets out to solve.
Right?
It essentially gives the LLM an external knowledge base. Like, here are the facts, stick to these.
An authoritative source it can check against.
Exactly. Giving it the grounding it needs to avoid those confident but wrong answers.
So when Meta, Facebook back then, first introduced RAG in their paper, the language was pretty academic, wasn't it?
Oh yeah. Very dense. Talking about, end-to-end differentiable models, information retrieval components, CQ-SEQ generator.
Right. Sounds intimidating.
Ugh.
But you're saying the core idea is simpler.
Much simpler, conceptually. Basically, RAG is about taking your own data, specific documents, facts, whatever, and feeding that into the prompts you give the LLM.
Okay, so you're not just asking the LLM a question, you're giving it the question plus some relevant information to use for the answer.
Exactly. All handled by some kind of retrieval tool behind the scenes.
And this simple idea, just adding data to the prompt, unlocks a lot.
Oh, huge benefits. First off, you're giving your facts right there in the prompt. That immediately helps ground the LLM, cuts down on hallucinations.
Makes sense.
Second, you can actually point to where the information came from, specify the sources. That's massive for verification and user trust.
Yeah, being able to check the source is key.
Absolutely. And maybe the biggest thing is you can use data. The LLM was never trained on, like your company's internal reports or just brand new information that came out yesterday.
Stuff that's too niche or too recent for the original training.
Precisely. There was a good quote from Ars Technica on this. They said RAG is basically like blending the LLM process with, like a web search or looking something up in a document. It helps the LLM stick to the facts.
So it's like giving the LLM research skills on the fly.
Kind of, yeah. And think about the practical side too.
Right, because retraining these huge LLMs all the time must be incredibly expensive and slow.
Exactly. It can cost millions, take months. RAG lets you bypass a lot of that. You update the external knowledge base, which is much faster and cheaper, and the LLM can use that new info almost instantly.
That's a massive operational advantage.
It is. And that source referencing thing we mentioned, that really changes the game for trust. You're not just getting a black box answer anymore.
You're getting an answer with footnotes, basically.
Yeah, you could put it that way. Verifiable answers.
Okay, so our guy sounds powerful. What are the actual pieces involved? You said it's conceptually simple.
It really is at its heart.
Yeah.
You basically need just 3 things to get started, conceptually anyway.
Okay, what are they?
First, you need your documents, a collection of them. Formally, people call this a corpus.
Right, the knowledge base.
Second, you need the input from the user, their question, their query.
Got it.
And third, you need some way to figure out which documents in your corpus are most similar, most relevant to the user's input. A similarity measure.
Corpus input similarity measure, that's it.
Conceptually, yeah. I mean, to really grasp the idea, you don't even need like a fancy vector stored database to begin with. You don't even strictly need the LLM just to understand the retrieval part.
Huh. That's interesting. It strips it right back.
Exactly.
Which is why that advice from Jerry at LlamaIndex makes so much sense. Build from scratch to learn, then build with libraries to scale.
That's a great philosophy for this.
So let's do that. Let's build a really simple RAG system, almost like a toy example, just to see the mechanics.
Okay, a foundational look.
Yeah, because understanding where this simple version falls short really shows why the more complex systems are needed.
Yes.
So imagine we have a tiny list of documents, our corpus of documents about, say, leisure activities.
Like what?
Things like take a leisurely walk in the park and enjoy the fresh air, or maybe go for a hike and admire the natural scenery. Just a few simple sentences.
Okay, got our tiny corpus.
Now we need that similarity measure. Let's use the absolute simplest one, Jacquard similarity.
Jacquard? How does that work again?
It's pretty intuitive, actually. You basically look at the words in the user's input and the words in one of the documents.
Yeah.
You count how many words they have in common, that's the intersection. Then you divide that by the total number of unique words across both the input and the document, that's the union. Usually after some basic cleanup like making everything lowercase.
Intersection over union of words. Simple enough?
Right. So we write a little function return response that calculates this Jacquard score for each document against the user input and picks the document with the highest score.
Finds the best match based on shared words.
Exactly. So if our user input is, I like to hike.
Okay.
Our simple system looks at the documents, calculates the Jacquard scores, and finds that go for a hike and admire the natural scenery has the most overlapping words. So it returns that sentence.
And it works. Basic RAG in action.
Yep. We just built a conceptual RAG application.
Perfect for that case. But uh-oh, there's a catch, isn't there?
There's always a catch.
Yeah, that Jacquard similarity. It's got a big blind spot. It has absolutely no idea about meaning, about semantics.
It just sees words that match.
Exactly. It's purely lexical. So what happens if the user input is, I don't like to hike?
Uh-oh, hike is still in there.
Right. So Jacquard similarity still sees hike as a strong match and it will still return, go for a hike and admire the natural scenery.
Which is the complete opposite of what the user wanted.
Exactly. Total failure on intent. And this really highlights something crucial, the R in RAG. The retrieval part, that's only half the story.
You need the G.
You absolutely need the G, the generation. That's where the large language model comes in to actually understand the context and the nuance.
Okay, so let's add the G. This is where the LLM brings its interpretive power.
Right. So the process gets a bit more sophisticated now. You still take the user input, you still use your retrieval method, maybe Jacquard, maybe something better to find the most relevant document or documents.
Still fetching the best match?
Yeah. But then here's the key step. You take both the original user input and the relevant document you just retrieved and you package them together into a prompt for the LLM.
Ah, so the LLM sees the question and the potential answer source material side by side,
Exactly. And the prompt is basically your instructions to the LLM. You tell it how to use the information. You could use an open source model like Llama 2, maybe run it through Llama, or go with a commercial one like GPT-4 from OpenAI, or Anthropic's Claude. Lots of options.
Okay, so let's go back to that tricky example, I don't like to hike.
Right, the one that failed before.
Before, our simple retrieval just spat back the hiking recommendation because of the keyword match.
Uh-huh.
Now we add the LLM and a prompt. What might that prompt look like?
It could be something like, you are a helpful bot that recommends leisure activities. Based on the following retrieved information, relevant document, respond to the user's request, user input, make a suitable recommendation.
Okay, so you're giving it context and a task.
Exactly. So now the LLM gets the input, I don't like to hike, and the retrieved document, go for a hike. But because of the prompt and its understanding of language,
It understands the don't like part.
precisely, it gets the negative intent. So instead of just repeating the hiking suggestion, it might generate something like, oh, I don't know. Sure, I can help with that. Since hiking isn't your thing, how about trying kayaking? It's another great way to enjoy nature from a different perspective.
Ooh, okay. That's completely different.
Right. It didn't just match keywords, it understood the intent and offered a relevant alternative.
That's the augmentation in action. It's not just retrieving, it's generating a genuinely useful context-aware response. That's powerful.
That's the magic of combining retrieval with generation.
Okay, so this basic RE setup, even with the LLM, is a great start conceptually. But obviously for real-world stuff you need more, right? There must be ways to improve this.
Oh, absolutely. Vast opportunities for improvement. And exploring those is really how we get to the sophisticated, complex RE systems people are building today.
So where do the improvements come in?
Well, several key areas. First, obviously the number and depth of documents. You move way beyond our little list of activities. You're talking about potentially huge, high-quality knowledge bases, enterprise scale sometimes.
Right? More data, but
how you store and retrieve that data, that simple Jacquard similarity, that gets replaced pretty quickly.
by what?
Usually by something called embeddings. These are numerical representations, vectors that capture the actual semantic meaning of the text, not just the words.
So it understands that running and jogging are similar, even though the words are different.
Exactly. Which leads to much, much more relevant retrieval. And you often store these embeddings in specialized databases called vector databases, which are optimized for finding similar vectors really fast.
Okay, so better retrieval through embeddings and vector stores. What else?
Another huge one is chunking.
Chunking, like breaking things up.
Precisely. Instead of feeding the LLM whole giant documents, which might be too much or contain irrelevant bits, you break them down into smaller, meaningful pieces or chunks.
Why does that help?
It makes the retrieval more precise. You find a specific chunk that answers the user's question, rather than a whole document that might only be tangentially related. There are different ways to do it too.
Oh,
Yeah. You can have fixed size chunks with some overlap so you don't lose context between them. Or you can use syntax-based chunking using tools like Spaci or NLTK to break things down by sentences or paragraphs intelligently.
smarter splitting.
Right. Or even file format-based chunking. Think about like an HTML table or a code block. You want to keep that structure intact, right? So libraries like Unstructured or LangChain help handle different file types appropriately.
That makes sense. Preserving the original structure.
And for really complex information, some systems go even further. They might convert the text into structured knowledge graphs.
Knowledge graphs, nodes and relationships.
Exactly. So the LLM can navigate connections between facts, not just retrieve isolated text snippets. It's really powerful for answering complex multi-part questions, sometimes called graph RAG.
Wow, okay. So chunking, knowledge graphs. Any other big improvements?
Well, there's hybrid search. That's where you combine the semantic vector search with traditional keyword search.
Why both?
Because sometimes keywords are really important. You don't want the semantic search to accidentally miss a crucial name or term. Hybrid gives you the best of both worlds.
Semantic understanding plus keyword precision.
You got it. Then there's the whole art of prompt engineering, crafting really good prompts to guide the LLM, making sure it uses the retrieved info effectively.
Getting the instructions just right.
Yep. And finally, a really critical one for practical use, updating the external data. That knowledge base can't be static. It needs to be kept current.
Right? Otherwise, you're back to the outdated information problem.
Exactly. So you need processes for asynchronous updates, maybe real-time streams, or regular batch processing to keep the information fresh.
That's quite a lot of layers of improvement over our simple example.
It is. And managing all that complexity, the vector conversions, the chunking, the retrieval strategies, the updates, that's where platforms and managed services come in handy.
Like, you mentioned AWS Bedrock earlier.
Yeah, Amazon Bedrock is a good example. It's a fully managed service that helps orchestrate a lot of this. It integrates with knowledge bases, handles vectorization and retrieval, and connects to various foundation models.
Making it easier to build these complex RAG pipelines.
Right. And often works with services like Amazon Kendra, which is an enterprise search service powered by machine learning. Kendra itself can handle things like retrieving multiple relevant passages, up to 100, actually from diverse sources.
And it understands different document types.
Yeah, tons of formats. And importantly, it can also apply things like document permissions and access control lists, which is crucial in an enterprise setting. You only want people to see the information they're supposed to see.
Security and relevance at scale. Okay.
So yeah, it gets sophisticated fast.
But even with all these improvements, RAG isn't like a magic wand that fixes everything with LLMs, is it?
No, definitely not. If we connect this back to the bigger picture, RAG is incredibly powerful, a huge step forward, but it's not a complete solution to all LLM limitations.
What are some remaining challenges?
Well, LLMs can still sometimes hallucinate around the source material, meaning even if you give them good facts, they might still extrapolate or add incorrect details in their generated response.
So they embellish the facts, potentially incorrectly.
Kind of, yeah. They might also struggle to recognize when the information they have retrieved just isn't sufficient to answer the question properly. Ideally, they'd say, "I don't know." But sometimes they'll still try to generate an answer anyway.
The overconfidence problem again.
A bit, yeah. And another tricky one is context interpretation still. A RAG system could retrieve sources that are factually correct on their own, but misleading in the context of the user's specific question.
Ah, okay. Retrieving the wrong kind of right answer.
Exactly. If it retrieves conflicting information, maybe an old fact and a new fact, it might struggle to reconcile them, maybe blending them together confusingly.
So, still some hurdles to overcome.
For sure. It requires careful implementation and ongoing evaluation.
But despite those challenges, it feels like RAG fundamentally shifts the balance, right? Makes LLMs significantly more grounded.
Oh, absolutely. It dramatically enhances their accuracy, their relevance, especially with timely information, and definitely boosts trustworthiness, because you can often trace the answers back to the source data. It's a massive improvement.
So wrapping this up then, we've seen how RAG takes that, over-enthusiastic new employee LLM
Yeah.
and turns it into something much closer to a knowledgeable, sourced assistant by giving it access to your specific current knowledge base.
That's the core value proposition right there.
And for you, the listener, this means things like more cost-effective ways to integrate AI with your own information, getting access to current, relevant answers, building more trust in AI outputs, and ultimately having more control.
Definitely brings AI closer to solving real-world specific problems.
It really does. So maybe the final thought to leave you with is this. What does this shift toward grounded, knowledgeable AI mean for how you might interact with information day to day? Or how could AI be tailored using RAG specifically to your unique world of knowledge moving forward?